Alright, so today we're going to talk about isotopes. The first thing you need to know in this section is isotopes are elements that have the same number of protons and electrons, but the number of neutrons change. So the element is exactly the same, except the number of neutrons have changed. Why do isotopes even matter? Well, isotopes are used in many medical practices. I showed you a slide of different radioactive substances that are used to help treat different parts of the body. Radiation for cancer treatments, heart treatments, and digital imaging techniques. Isotopes are also useful in biology for carbon dating, and knowing the half-life of carbon helps date how old certain things are. Isotopes are everywhere in nature. Isotopes occur regularly all through nature, so some radiation occurs naturally through all nature. For instance, bananas, they have 3 different types of isotopes or radioactive materials. So when you're eating a banana, you're eating something radioactive. Nope, you're not going to glow green, unfortunately. That'd be pretty cool, though. So there are 2 ways that you can see what an isotope is. The first way, you see the A over Z with the X. And the second way, you have an X-A. So the X is the element that you are talking about. The A is the mass number, and then Z is the atomic number. So the bigger number will always be on top in that first one, or it just gives you the the mass number. So if X is fluorine and its mass is 20, then the correct way to put this would be fluorine, or F20. If the atom has a charge, the charge is written in the upper right side of the symbol, but we will not really talk about the charges as much in this section. That'll be more later on when we talk about ionic bonds. So determine the number of neutron in each isotope. I'm going to do some examples with you guys, and then to review how you find the number of neutrons, you subtract the mass by the atomic number. Now, instead of using the mass on the periodic table, you're just going to use the mass that they give you because it's different, because the number of neutrons have changed. So now I'm going to do some practice with isotopes. And with this is laid out just like how your practice page is on your next slide or on your isotope practice page. So I'm going to show you how to do that. So here we are given our isotope name. It's the element, and then it has a number. This number is your mass number. Okay, so whatever number they put next to this is your mass number. Now to find your atomic number, just as a reminder, you look at your periodic table. So here boron has an atomic number of 5 because that's the smaller number. All right. So let's start filling this out, and I'll go over how I get that. So the atomic number for boron, again, we look at the periodic table, and it's the smaller numbers. So for boron, it's 5. So we will put a 5 in the atomic number. Now, if you want to go ahead and skip, the atomic number is always going to equal the number of electrons and the number of protons, so you could just put a 5 there. Okay, now your mass number. Don't look at the periodic table, because that is what's different about isotopes than everything else. You look at this number. So whatever number is written out is what goes with your mass number, 11. Now to find your number of neutrons, do your mass number minus your atomic number. So in this case, it would be 6. Okay, so you do everything the same except your mass number is written out here instead of looking at the periodic table. So let's look at carbon. Carbon 14. All right, so our atomic number is going to be on the periodic table. So carbon has an atomic number of 6. It's that smaller number. So we'll put 6. The mass number right here written down, so it'll be 14. Electrons and protons will be 6 because these two are always the same. Then you'll do 14 minus 6, which is 8. So you have 8 neutrons. Lithium. Find lithium on your periodic table. It has an atomic number of 3 because that's the smaller number. So a 3 will go right here. Your mass number is written right there, so that'll be 8. Electrons and protons is the same as the atomic number. 8 minus 3 is 5. So you have 5 neutrons. So that's how you work that out. It's very similar to what we did last unit. The only difference is the mass is right here, and that's what's different between a regular element and an isotope. If you have more questions, if you're not sure where I'm finding these numbers, let me know. I'll be happy to help, and I hope you have a great day. Once you have finished going over the practice problems, you will need to come over here to the isotope practice and type in, I made a text box for each square so you can type the answers, and I will show you how to do this on the whiteboard as well, or I've already shown you how to do this on the whiteboard. So if you have questions on how to do this, let me know and I will be happy to help you.